In section 2.4, we learned that we could find the derivative f prime of x by taking the limit as h approaches 0 of that difference quotient. Well, that takes a long time. It's a four-step process, and we only did polynomials. But could you imagine having to do that on anything where you have a square root or a negative exponent? It would get a little tricky. So what we're going to do today is we're going to learn shortcuts. We're going to learn shortcuts to finding derivatives. Now, before we learn the shortcuts, let's get some notation down so that we can all be on the same page in terms of what we're looking for here. So now, if you're given y equal f of x, then the derivative of that function can be represented by f prime of x, y prime, dy dx, ddx of f of x, or just the derivative of f of x for the last one. So any of those things, if you are asked to find, if someone's saying, hey, find f prime of x, or find y prime, or find dy dx, or find ddx, then that means you need to find the derivative. All of those things are different notations for the derivative. So let's learn some rules. Let's figure out some rules for finding the derivatives so we don't have to go back to that limit process. We will have one of those on our exams, and we will need to know how to do that. But how do I avoid having to do my four-step process? Rule number one, the derivative of a constant. Given that c equals a constant, didn't write that down, the derivative of a constant is equal to 0. Derivative of a constant is equal to 0. So if I say find the derivative, find d dx, well, if f of x is equal to -3, hey, this guy here is just a constant, then f prime of x is equal to 0. The derivative of a constant is equal to 0. What if I give you that f of x is equal to 1.735? Well, that guy there is still a constant. The derivative of a constant is equal to 0. The derivative of a constant is equal to 0. Next then we're going to look at is the power rule. If n is any real number, so if n is any real number, then the derivative of x to the n is equal to n times x to the n minus 1. So you take this n and you bring it out in front and you multiply, and then you raise it to 1 power less. So find f prime for f of x is equal to x to the 5th. So instead of having to use that limit process, right, that four-step thing that we did before in section 2.4, we're going to use this shortcut that says, hey, if you have x raised to a power, what you do to find f prime of x is you take that power and you bring it down and multiply. So this is going to equal 5 times x to the, and you raise it to 1 less. 5 minus 1. Well, what's 5 minus 1? 5 minus 1 is 4, so this would be 5x to the 4th. I'm going to be skipping to what I boxed pretty soon. What about the next one? X to the 2.1. 2.1 is a real number, so if I want to find y prime is going to equal, again, this multiplies out in the front, so 2.1 times x to the, well, whatever 2.1 minus 1 is, well, 2.1 minus 1 is going to equal 1.1. So this is going to be y prime is equal to 2.1 times x to the 1.1. And if you have trouble with those, you can always do those on a calculator, right? 2.1 minus 1, 1.1. So this is y prime is equal to 2.1 x raised to the 1.1. Find dy dx for y equals x to the 7/4. So dy dx is going to equal, again, that 7/4 becomes a constant multiplier. So 7/4 x to whatever 7/4 minus 1 is. And again, you can use your calculator for that. Dy dx is going to equal 7/4 x. And then let's figure out what the 7/4 minus 1 is. So 7 divided by 4 minus 1. And let's make this into a fraction. So I'm going to hit math and then enter twice. 3/4. So if y is equal to x to the 7/4, the derivative of y with respect to x, or dy dx, is equal to 7/4 x to the 3/4. Now notice this time I wrote 3 different ways of representing the derivative. And you have to feel comfortable with all of these. F prime of x, y prime, dy dx, they all mean the same thing. They're just the derivative. One more. For this power rule, the derivative of the cubed root of x. Well, when I looked at the power rule above, it was x to the n. So I know that the derivative of x to the n is equal to n times x to the n minus 1. But this isn't an x to the n, that's the cubed root of x. Very important. You have to remember this. You'll see this throughout calculus. If you have the square root of a, that's equal to a to the 1/2 power. If you have the cubed root of a, that's equal to a to the 1/3 power. The fourth root of a to the 1/4 power. So in general, the nth root of a is going to equal a to the 1 over n. So whatever that little number is the number that's going to go into your denominator. So the first thing I'm going to do to find the derivative of the cubed root of x in number 6 is to rewrite the cubed root of x as something with an exponent. So the cubed root of x, this number goes in my denominator. This is the same as the derivative with respect to x of x to the 1/3 power. Cubed root is 1/3 power. Well, what's the derivative there? Again, remember this guy here multiplies out in front. So that's 1/3 x, and then it's going to be whatever 1/3 minus 1 is. And let's skip to just grabbing the calculator to figure that out. So 1/3 minus 1. Hit enter, and then make it a fraction, and it's negative 2/3. So the derivative is equal to 1/3 x to the negative 2/3. So the derivative of a constant is 0. Then we have the power rule. The derivative of x to the n is n times x to the n minus 1. Let's look at the constant multiple property. So the constant multiple says, hey, if you have some number that's multiplying your function, and you want to find the derivative, well, constant multiples just multiply along. It's the same as that constant times the derivative of the function. So let's do that in number 7, and then we'll kind of show you the shortcut as well. So if I want to find y prime for y equals 7 times x to the negative 12th, well, 7 is that constant multiplier. So what it's saying that you can do is you could just find the derivative for x to the negative 12th and then multiply it by 7. Well, what's the derivative of x to the negative 12th? Well, this is just the power rule. The negative 12 comes out and multiplies, so negative 12. And then it's going to be x raised to 1 power less, so negative 12 minus 1 is negative 13. So if I wanted to find y prime for 7 times x to the negative 12th, well, my y prime is going to be 7 times whatever I just got here, which is negative 12 x to the negative 13th. Well, what is 7 times negative 12? Well, 7 times negative 12 is going to be negative 84 x to the negative 13th. So we end up with negative 84 x to the negative 13th power. So shortcut, because we don't want to do all this. It's a lot of work, right? So what you always do, if you've got a constant multiple, so again, I'm just going to write it over here. We have y is equal to 7x to the negative 12th. You take this number here, and you always multiply it to your constant multiple. So 7 times negative 12 is negative 84x. Raise it to 1 less. Negative 12 minus 1 is negative 13. Notice we get the same answer, just less work. Number 8, find dy dx for y equals 9x to the 1/3. Same thing as we did before. Dy dx is going to equal, you take your 1/3 power and you multiply it by 9. So we could do that on a calculator if needed. So on a calculator, 9 times 1/3 is going to be 3. So 3x to the, and then it's going to be whatever 1/3 minus 1 is, and 1/3 minus 1, again, make that into a fraction, and you get negative 2/3. So it's going to be 3x to the negative 2/3. So the derivative of y equals 9x to the 1/3 is 3x to the negative 2/3. What about number 9? Well, number 9, anytime you have a radical in this course, you're going to want to rewrite it first. Well, how can I rewrite the square root of x so it becomes a power? Well, remember, when you have the square root, the index or that little number is the number 2. So you can rewrite this as 3x to the 1/2 power. So we multiply 1/2 times 3 is 3/2 x, and then we subtract 1/2 minus 1, and again, you can use the calculator for that. I'm going to stop using the calculator. I think you guys can do that on your own, and you end up with negative 1/2. So the derivative of 3 square roots of x is 3/2 x to the negative 1/2. Find g prime of r for g of r is equal to pi r squared. Remember, pi is a number. It's approximately 3.14, making it a constant multiple. Therefore, if I want to find g prime for g of r equals pi r squared, again, you take this and you multiply. G prime of r is going to equal to, well, pi times 2 is 2 pi r raised to 1 less. 2 minus 1 is 1. So the derivative of pi r squared is 2 pi r.